Projectile motion can be seen in various situations in everyday life, such as basketball. Golf.
Football.
Throwing tomatoes. Choking. Projectile vomit. Hitting things. And even reckless activity.
And now, to the physics.
Ian is chipping on the golf course. He is using a 56-degree lofted wedge. When he strikes the ball, its initial velocity is 10 meters per second. The ball falls straight in the hole. How far away was the hole from Ian?
We want to start off by drawing a picture. So the golf ball is moving upwards at 10 meters per second. At a 56-degree angle. So you want to find the x-coordinate velocity and the y-coordinate velocity. We will start by finding the horizontal velocity of the golf ball. The equation that we use for this is v0x equals v0 times cosine the angle of launch, which is 56 degrees. So what we will have is v0x equals 10 meters per second times cosine 56. We will now go to a calculator to do the math.
We'll start by plugging in the initial velocity, 10 meters per second. Then multiply that by cosine the launch angle, 56 degrees, giving us 5.59 meters per second.
After solving the equation, we got 5.59 meters per second for our horizontal velocity. This will come into use later in the derivation.
Be sure to note that the x velocity is a constant and will remain the same throughout the ball flight.
Now we will find the vertical velocity of the golf ball. The equation is very similar, but instead of cosine, we use sine. So v0y equals v0 times sine 56.
Also note that the vertical velocity will slow down before it reaches the apogee and then speed back up.
So v0 y equals 10 meters per second times sine 56. We will now go to the calculator to do the math.
Similar to before, we still use 10 meters per second as our initial velocity. Instead, now we multiply it by sine 56 because we're now finding the horizontal velocity. This gives us a sum of 8.29 meters per second.
Now that we have figured out that our vertical velocity is 8.29 meters per second, we can calculate the change in velocity from the apogee to the golf ball hitting the ground. The equation for this is delta t equals the change in the vertical velocity over little g. Note that this is just from the apogee to the ground, not the total time that the golf ball is in the air. This is equal to negative 8.29 meters per second, and the rate at which this velocity is changing is negative 9.8 meters per second. We will now go to the calculator to do the math.
First, you plug in the vertical velocity, negative 8.29 meters per second, divided by gravity, negative 9.8 meters per second squared. This gives us 0.8459 seconds.
We figured out that from the apogee to the ground, it takes 0.8459 seconds for the golf ball to fall. Since this is not the total time that the golf ball is in the air, so our time total is double this, which is 1.69 seconds. Since our original equation started with only 10 meters per second, we want to put this into one sig fig. So our final answer is going to be 2 seconds. Now, we will be finding the total distance that the ball traveled in its flight. The equation for this is delta x equals time total times v naught x. This is where the horizontal velocity comes into play. So we have delta x equals 1.69 seconds times 5.59 meters per second. Notice that we are using the unrounded values to be as precise as possible. We now go to the calculator to do the math.
We start with the total time, 1.69 seconds. Then multiply this by the x velocity, 5.59 meters per second. This gives us 9.4 meters.
After doing the math, we have found that the total distance that the golf ball traveled was 9.4 meters, which rounds to 9. So, with the whole shot, the golf ball traveled 9 meters in the air and landed into the hole.